Hey, class, we're back. What I'd like to do is move on from these traps. Turn this a bit. Okay, the P trap, also known as a half S trap, is uh, is really the only legal trap that we work with. Later on, they're going to cover the drum trap. Drum traps are a little tricky. Now, let me show you something about a drum trap. I think it will pop up later on in this. Let's see if it leaves the next page. And if I remember right, they just say that it's a legal trap. Not too fast on that one. Yeah, here it is. Two traps that are acceptable: a half S or a P trap and a drum trap. Okay, first of all, the drum trap is never acceptable in a new installation where you can install correct proper vents and drains. Right? Nobody's gonna let that go by. So don't even think about a drum trap for that. Now, if you're working in a town where you know the inspector, you know the drill, if it's remodeling, it's impossible to put a vent in without tearing the house apart because that's the way that it was done originally. Most inspectors will probably let it go. I've run into only one that made me tear the house apart. It took me like 2 days to put vents in, and I was knocking out a lot of walls to do it. Uh, but the drum trap is really with the inspector's permission. So if you're going to have an inspection and you don't know the inspector, give him a heads up before you get to that point, okay? Because it paid off for me. That job that I did where I had to vent everything, sure, when I was done, it was a really nice job. It was all vented. But the bathroom originally had no vents and it was not on the top floor. So I had to like somehow get vents up to the attic and if I remember, I had to take it out the roof. So be careful about a drum trap. But first of all, let's talk about drum trap. How they work. Okay, drum trap looks about like this. Clean out down here, right? Water comes in here and goes out up here. Now, if you're thinking that looks a bit like a full S trap, yeah, it does. But whether it goes straight in this way or it goes down here, it's still a drum trap. Now, why would you have it go straight into the wall? Why would not you choose a P trap? The reason a drum trap might have been used is because inside the wall might look like this, right? This could be, let's say the wall was here rather than going through the cabinet. If there's no vent on top of the elbow in the wall, then you get an illegal setup there. There's no vent. So the drum trap works like this. The body of water is very large, right here. Okay, so the water is always that deep. And the idea is that this cylinder is much bigger than the pipe. For example, if this was an inch and a half drum trap, it would be a 3 by 6 by 1.5. Right? That's how you write it. So it's 3 inches across, 6 inches tall, and inch and a half in and out. Okay. The idea is that a large body of water like this cannot be siphoned. All right, or it's very hard to siphon it out. Where an S trap is easy to siphon, right? Uh, if you throw enough water in at enough velocity, that's why our standpipe on a clothes washer is only 30 inches. If you go too high, and I've seen one being on up on the second floor, if you go too high, you could siphon it out. But a drum trap, no, because this is really like a 3 inch pipe right here, and there's not much chance that there's going to be enough velocity coming in to empty it. Now remember, when you go from one size and you double it, for example, inch and a half to 3 inch, the capacity changes, increases by quadruple. All right, an example would be this. Let's say we had a 3 inch square like this here, right? If it's 3 by 3, that's 9 square inches, right? Inch and a half by inch and a half would only be like 2 1/4. So it's okay. In other words, if I did 1.5 inch square inside here, each 1.5 inch would only be a quarter the size of a 3 inch. So if you round everything off like this, this makes the math easier. You'd see that there's not much chance that a pipe only a quarter the size, volume-wise, right here, of this could be siphoned. So that's why we have drum traps. Now, the size of one that you don't see very often, in fact, I suspect that most of you have never seen, is a 4 by 8 by 2. Now, I've only used this a handful of times. It's very big. And as you can tell, it's 8 inches high. So you got to have a pretty good sized floor joist to fit it. This would be for a shower. And in fact, I've tried to get it. And I've asked a few times, and the suppliers don't even have it in stock. So it is available, though. It was made. I have used it. And I've seen it, but only in PVC. Now, this one here was also made in copper. Some of you guys have probably removed them when you're doing remodeling work. And it's roughly the same dimensions as the PVC, like 3 by 6 by 1.5 inches. Because it's copper and it's a little thinner, it's slightly smaller overall, but it's the same. Does the same job, just copper. Okay, so drum traps. Let's do a few names for drum trap. Okay, first of all is the drum trap. Anti-siphon trap. It's probably the best name. Tells you what it does. Bottle trap. Although this one here, I got my doubts whether that's the right name for it. If that's what your boss calls it, that's what it is. All right. A couple of names that are out there. There might be more. That's the only ones I can think of. Okay. Now remember, the trap, P-trap, I'm going to get rid of this here. Drum trap, remember, strictly remodeling where there is no vent, not being inspected, or if it's being inspected, you better check in with the inspector before he shows up and sees this and doesn't like it. Could happen. Happened to me once. But I had been warned in advance that the guy was tough, and fortunately I checked. Okay, a trap. One last thing about traps before we move on. The depth of the trap is 2 to 4 inches. So from here to here, right? Anything below that, then the trap seal is going to be broken. So from as high as it can go before it runs out to as low as it can go is 2 to 4 inches. All right, that's the design. We're not concerned about that. The traps that you buy at the supply house, as far as I know, they're all legal, unless you get a metal trap and like a chrome trap. Remember now, the only legal thickness on chrome brass would be 17 gauge, right? And you'll see it right stamped on the trap. If it's 20 or 22 gauge, don't use it. Not legal. And it's easy to tell. If you can't find where it's in size, it's like stamped right into the metal. If you can't find this, you can tell. If you can take it in your hand and squeeze it, you'll never squeeze 17 gauge. It's not going to happen. But 2022, you can, especially 22. These would be your tail pieces on a kitchen sink, dishwasher tee, the different types of dishwasher tees, the arm, the waist arm going over to the second bowl. They come this thin, and I don't recommend them at all. In fact, I think most of you guys are probably using PVC these days. Okay, but this is code 17. Okay. One last thing. I mentioned this and I did not finish. We have a lead piece of pipe at the floor level coming like this. It looks like this. And we'll say the floor level is the same height as this here. And the escutcheon was covering it, that raised washer type thing. And you have a piece of lead coming down. I mean, This is the lead. You have the chrome trap coming down, whether it's okay like that. These pipes would be the same size, of course, and this would catch where it's flared out. So how do you do this? If this is chrome, okay, here's what you do. You get a file, fine metal file all the chrome off, maybe an inch high, right? Keep turning it, filing it, turning it, filing. Eventually you'll get all the chrome off, most of it. There'll be a few spots here and there. Get a brand new piece of sandcloth and really crank that up to the point where it actually heats up the pipe, right? As you heat it, as you turn it. Once you get it all off, or as much as you can off, then what you do is clean up the lead before you put the pipe in, like this. Clean up the lead, make sure there's no holes, and get any kind of dirt, grime, whatever's in there, and put a little bit of flux on the lead and flux on this here. So you would have maybe flux it up maybe to about there. Okay. Then get your torch. Now this is a tricky part. The scutcheon now is up here somewhere, up out of your way. All right. Heat this and use 50-50 solder. It's the coolest solder we have as far as the temperature. It melts at 400 degrees, I remember. And melt the solder and heat this up. Don't touch the lead with your torch. It'll just wilt because it's solid lead and it melts very easily. So put the heat on here and a little bit of solder and kind of fill this up. I don't know if this color has come out or not. I think one of you said that color doesn't show up. Anyway, fill this up. Ideally, what you want to do is fill this up with solder right to the, like that. Almost like you're doing a caulk in a joint. Okay? And get yourself a pretty good seal. That's it. Okay, that's probably how it was installed 75 years ago. So that's one way you can get out of it. And this could be, like a piece of chrome brass. You cannot solder the chrome. So file it off and then do this here. All right, nice little trick. Now the one last trap I want to make a note of, a very quick note, is the one that looks, let's see. Comes in down low like this. This is all chrome. This is the clean out cover, I think was right here. And it comes right off the top like that. Check with your boss. I think the name is a Bristol, but it's chrome, very expensive. If this is less than $100, I'd be surprised. Very heavy, very thick brass. This is obviously just a form of like a drip trap because it has the big body here. I think my body might be a little bit too small in proportion of the pipe, but this would be like 1.25 inches in, 1.25 inches out, or 1.5 inches. And the idea is rather than a full S trap, this shouldn't siphon. So this isn't a form of anti-siphon trap. There was one. Those of you who were in school last year, in the men's room under the sink, there was one of these. All right, you don't see them too often these days, but there's one there at the school. So if you ever get back to in person at the school, you'll see one. Okay, so that's it for the traps, and let's move on. Okay, next one, number 49. Can you connect ABS and PVC together? What do you think? The answer is no. No, we can't. But they don't really explain it. Technically, that's correct, but here's what I'd like you to add. No, they cannot be cemented together or glued together. Either that's interchangeable. Cannot be glued together. However, they can be joined with a transition fitting. So if you look on page 108, now this one I'm giving you, page 108, transition fittings. They don't say it, but what you would use there would be PVC male to like a ABS female, Teflon or pipe dope that's suitable for either one or both, and that's fine. Okay, that'd be an example of transition fittings. Now, those of you who do it quite often, perhaps something like a Frenco or one of those other kind of couplings would be okay. But the male to female is an example that I know is legal. Okay, now this one here, 5 piping materials that can be used on both waste and vent above as well as below ground. Okay, they mentioned waste and vent. Also, in the book, they call it storm and sanitary. So if you look on page 102, they give you a list of below ground. And below ground, we can use all of the ones that they list on the number 50. All right. So let's go over those. Extra heavy cast iron. Extra heavy cast iron is the bell and spigot, the one with the lead Nokum, or resilient gaskets. And then we have the lighter version of it, surface weight, with either a lead Nokum or resilient gaskets. Again, this is underground. And this one here is, I've never seen this, but I know some of you guys have done it. I know we've talked about this. No hub, which is the generic name for no hub, is a hubless cast iron. And that one there is very tricky. You have to hang it underground. You actually have to put hangers on it and hang it like from the slab. So you put a threaded rod up and then like a ceiling plate, so it would be something to grab onto where the concrete would be poured. And if I don't have the book right here, but I believe it said there, I know it said that you have to have the inspector take a look at this, right? So again, if your company wants to use no hub underground, or that's what the specs call for, that's what you do. And maybe somebody who's done this could give us a little bit of insight into how this was to install. Like I said, I have not done it. I've done resilient gaskets, and when I was a kid, I remember in the '60s we were using just lead and oakum. There was no resilient gaskets. PVC and ABS, they're okay underground. Right now, what they don't mention here, and I will mention it right now. I think it comes up, but it's pretty far along. The next question I would have asked here is, what is some material that can be used above ground only? Because the ones that we just used are the ones that are on the heavier, more rugged side because they're underground. Now, above ground, you can make a note of this. You can use above ground only, type M, type DWV copper. Now, obviously, that we're talking probably a commercial job. You wouldn't be running it these days for residential, but technically it's legal, but only above ground. Now, they don't mention it here, below ground, but you can add to your list below ground, number 50, type L and type K copper. That's legal underground. That would be like up to 7. Now, let's go back to what's legal just above ground. There would be galvanized black steel. Black steel has been coated with zinc is called galvanized. That's legal, but only above ground, not underground. Okay, so there's some pipe that can only be used above ground. Your 2 types of copper plus galvanized. How far do you space hangers on 1.5 PVC and less? I guess what they mean is smaller pipe. Now, we normally don't work with pipe smaller than 1.5, but once in a while, maybe a condensate drain up in an attic for a central heating, right? Hot air central heating / AC. I think I've run maybe 3/4 inch PVC. They say here you can hang it every 3 feet. I suspect I never use PVC that small, and that time I did, I don't remember. They say 3 feet is okay. You can hang it 3 feet. All right. But for us, usually the smallest we work with is 1.5 inches, so that's it. That's the only one you need 3 feet. Now, on a regular job, think about 3 feet. That's 2 floor joists, 1632, and then 4 inches. Now, I don't know anybody that hangs at every other floor joist. You skip one, right? You go to the third floor joist, but that's 4 feet. That's where an inspector could pick you up. So if I was an inspector and I was looking to pick somebody off because they'd been a wise guy or whatever, this would be one. Because I suspect that most guys do not space their hangers at 3 feet. Okay, when you go over 1.5 inches, 2 inch, you want to make a note there, 2 inch on up, the spacing is 4 feet. The pipe is more rigid, and 4 feet is just fine. Now, I don't see the question here, but I'll mention it. It's a typical PVC question. What kind of hangers? How wide does the support have to be on a hanger? The answer is 3/4 of an inch. So a regular PVC hanger has a surface area 3/4 of an inch wide. Strap iron, band iron, same thing. A-band, clevis. I've seen people use clevis and A-band, actually commercial in Rhode Island many years ago. That's what they were using on some work at town hall. You can use them. It's expensive, but they're legal. What you can't use on PVC, J-hook. They're only about 1/4 inch wide, maybe a little more. What's another one? F&M hanger, not good. Right, they're too small. The surface is too small, and I guess the idea is that they can kind of cause a bump in the pipe right where the hanger is because it's not wide enough to spread out the weight. In any case, be careful what hangers you use on PVC. Okay. Let's try page. This is page 7. Where do you provide expansion joints on a stack? Okay, now the only thing is that's worded correctly, but remember, as soon as you say a stack, that means vertical. So an expansion joint. Now this is the one that's clear plastic. It looks like a coupling, clear plastic, slid over a smaller, almost like a coupling, with 2 O-rings that are visible with a lot of grease. Okay, and the idea is that if it was glued, it would actually be able to move back and forth, sealed by the O-rings, right, and the grease, so it wouldn't leak. So what they're saying is, if you have a stack, I put vertical on here. I think when Maureen sends these to you, you'll see it. This is my copy. It's every other story height, so you could put one between the first and the second floor, or actually between the let me see, where's the second? You could put one in the basement, right? Let's say you got a bathroom in the basement, and you have one on each floor up to the third. You could put one between the basement and the first floor, and skip the next floor, which would be the first to the second, and put one on the third floor. I don't think it makes any sense, but that's what the book says. It's every other story height. They call it every other branch interval. Remember that term. Branch interval is a story height. Okay? Branch interval is 8 feet or more, usually 10 feet. Now on horizontal runs, this is where I actually used to use these things. I don't think most of you guys aren't using them anymore, but it's still in the book. PVC expands quite a bit. 3/8 of an inch, remember that? For 100-degree temperature change, 10-foot length. So where do you need expansion joint? Any straight run exceeding 20 feet in a private home, you got to put an expansion joint. Usually in a private home, you don't run 20 feet before you angle off, you cut off at an angle to go somewhere. So that probably would save you. What I'd like to know, though, is if any of you have been using these expansion joints in the last few years. And now they've got 3 ways to connect cast iron pipe. We got lead and oakum, resilient gaskets, and we have clamps. Now the clamps would only be for no hub. All right, we normally wouldn't use a clamp on surface weight or extra heavy. Now that brings up a good point. Remember that in the last video, I showed you how you just put a piece of no hub in, which some of you guys have done many times. But if you remember, if you're putting it into cast iron, the cast iron is either surface weight or no extra heavy. right? I've never seen no hub wear out. So you're probably replacing a piece of old service or extra heavy. The problem is service weight is too thin, extra heavy is too thick compared to no hub. So if you put the clamp around the no hub and you got extra heavy, it's going to bulge out. And if it goes the other way, if you got service weight on the top and you got your no hub, now it's going to be the other way. It's going to be too small on the service weight and too big on the extra on the no hub. So what do? Those of you who've tried to crank it up and tighten it down like that, you notice that it ripples the clamp. The metal clamp looks terrible, right? One way to get around it is to get some rainbow packings, that red rubber that you buy by the square foot, and you just cut like a gasket out, right? And fatten it out, fatten out the no hub, and put it in, and you find that it comes out pretty good. And the other way around, if you got extra heavy, fatten out the no hub, and that will also bring you pretty even so that it looks a lot better when you tighten up the clamp. Now, where that piece of rubber wraps around, you might want to put some pipe dope there so you don't want it to leak right there, right after all your hard work. Okay, but that will help you go from two different types of cast iron, get you around it. But normally the clamps we reserve strictly for no hub. Okay, they mentioned where lead and oakum these days are used uh, rather than no hub. One of them is cleanouts. I guess that's so it doesn't rotate the clamp. So they want it with an end clean out, bell and spigot pipe, of course, and a urinal. Okay, the urinal, they don't want to use gaskets around a urinal because it would the acid in the urine will eat burn through the rubber gasket. Now they mentioned what should be placed over uh, DWV, not DMV. That's Department of Motor Vehicles, I guess. Change that M to a W, please. And PVC drain pipe. Okay, what they're saying here is if you have a trench and you're putting PVC, copper, any pipe down there, really, even cast iron, you don't want rocks falling on it. So they say 6 inches of sand. That would be a minimum. Because if you put your sand on there and then you got a backhoe could handle a couple 100-pound rock that wouldn't even know it was in there. And it could go down and crush the pipe. But with the sand on top, you're probably pretty safe. And in fact, I've had inspectors say they want to see the rough plumbing, and then they want to see before the cement is poured to make sure that I use sand or something suitable, something fine like sand, like dirt, before it was backfilled, before it was, covered up with concrete. And they're repeating that hanger. I don't know, but we're repeating the hanger spacing again, 3 feet. All right, distance between hang. All right, and here it is again, 4 feet for over inch and a half. Okay, I'm going from cast iron to PVC transistor fitting. Okay, and they're also mentioning the transistor fitting again. If the shower pan, anybody here has done a mud shower? I wish I could ask you in person. A mud shower, if you hear that term, is just a slang name that we give to the handmade showers. Some of your high-end customers will have, especially like an existing house remodeling, where they have a closet and they decide, okay, let's make the closet into a shower. I've seen this a few times. As long as you got the depth, you can't have anything less than 30 inches, right? So if it's 28 inches deep, 5 feet long, you want to do it, go right ahead. Don't get it inspected, right? You need 30 inches both ways minimum. Okay, finished. So you're going to put up half-inch cement board on either side, plus some tile. You're probably looking at close to 32 to be safe. But that's not your call. But you could warn them because you can't get an inspection if it doesn't measure that much. I've never had that problem because the ones I've done were always plenty big enough. So what you do is take the measurements between the studs all around, go see your sheet metal guy. Have somebody you deal with. I did in Tiverton, Metalworks. They're still there. A little high, a little expensive, but they did nice work. And I'd give them the dimensions. What they would do is deduct like a quarter to a half inch all the way around so that the pan would drop right in. If they cut the pan to your dimensions, you got to beat it into place with a 2x4 and a hammer. Right? You don't want to do that. So be sure that they make it a little bit smaller. So what I used to do is give them the dimensions, and because a few of them I had a little problem. He said, "Give me the dimensions. I'll take off how much I want." I said, "Fine," and it worked out just great. So that would be a mud shower, and you would use the copper pan. They call it 12-ounce copper. Again, leave it up to them. Okay. What's the distance from the water closet outlet to the center line of the drain? All right, the answer here is 20 inches. Why don't you put that maximum? Okay, here's what they're talking about. I do remember seeing this in the code. There it is. This is your closet flange right here. All right? All right, that's the one that pops up for a test question now and then. Normally, we don't have to deal with this. Now, the only time you might see something like that is if you got a truss floor. You know, the floor that looks like a series of W's and you want to get under it. I guess you could, because the truss floors are somewhere around, what are they, 16, 18? I guess it depends. The truss depends on the span. The longer the span, the taller the truss. But otherwise, I can't imagine going more than this. This is not usually a problem, but a good test question. So where you see that 20 inches, you want to make a little sketch off to the side, go right ahead. Okay, and this other one here is also, actually there's two questions right there. This is not one that you normally would know off the top of your head. From the outlet of a lab to its trap is 24 inches. Okay, so okay, this is 24 inches. Okay, again, this is also one that doesn't come into play. In fact, I've never seen it. You know, really, where you got the outlet for your trap, what are you, 17, 18 high off the floor? How could it be 24? The thing would have to be up in the air. But the book says that to the trap, 24 inches. Now, I take that to mean the entrance to the trap, which would be right here, right? So that's where I would say the 24 is measured to, not the bottom of the dip. Okay, so there'd be a pipe here, 24 inches long. Okay, and they call that the developed distance. Another nice thing to remember. Okay, I'm going to wrap this up. I did not make a note of the time. I think it's about a half hour. So I'm going to wrap this up. And let's see what we got here. Okay. I will see you guys in the classroom.